Hey guys, welcome back again. So this is the video series. This is going to be the video series where we're going to be dealing with the MCQs related with the foundation engineering and the soil mechanics problems. So both the MCQs, MSQs, the numericals, whatever we'll encounter, we'll be doing each and everything. So this video lecture is solely be about mm, the soil mechanics and the foundation itself. Yeah, so we'll be dealing with three, maybe 300, 400, or more, maybe more than that number of questions. Okay, so without further delay, let's get dive into it. Okay, so here we have a first question, that is the lateral earth pressure on a retaining wall is equal to the mass of the soil retained, proportional to the depth of soil, proportional to square, proportional to internal friction of soil, none of these. So the right answer of this one is the it is proportional to the internal friction. It is proportional to the internal friction of the soil. Okay, so moving to the next question, the minimum water content at which the soil just begins to crumble when rolled into threads 3 mm in diameter is known as liquid limit, plastic shrinkage, permeability. So they have given the definition itself. So if we remember the definition of plastic limit, will be then it is very much easier us to mark the right option. Okay, so the answer is the plastic limit. Answer is the plastic limit. Okay, so third question, mm, pick up the correct statement from the following. The rise of the ground surface due to first action is called first wave. Yeah, this is called first wave. The freezing point of water is accompanied by a volume increase of 9%. So it is basically in between 7 to 10%. When the water gets freezed, then obviously it forms into the it turns into the ice, whose volume gets increased by 7 to 9% of that of the mm, if you compare with the same volume of water when it was in liquid state. Okay, so below freezing point, higher soil suction develops. Yes, the magnitude of first heave decreases as the degree of saturation of soil decreases. Obviously, if the content of water is going to be decreasing, then first heave will not take part much more, and the vice versa. So the option will be this one, E option. Which one of the following statement is true? Clays are more porous than sands. Yeah, because the clays contain much more smaller particles as compared with the sand. If we talk about the size, then the size range of clays varies from mm, less than 2 micron to up to 2 micron. But if we compare with that of the sand, then then it is about uh, up to 4.75 mm. Okay, 6 micron to 0.06 mm to 4.75 mm. Okay, so pressure of organic matter in a soil decreases. The bearing capacity of soil, yes. Aluminum cement is used for foundations in soils with chemical deposits, yes. So all the options are good, all are right. So no problem. So we'll be marking the option D1 as the right answer of this question. So the internal molecular attraction of soil, the cohesion. What will happen in the intermolecular attraction between the particles of a soil if we decrease, if you know, decreases as the moisture content decreases. With the increase or decrease of the moisture, what will be the property, or how the cohesion property of the soil will behave like? So this is what the question is telling. So the first option is decreases as the moisture content increases. Yes, it is also somehow good. Increases as the moisture content decreases, not so good. Is more in well compacted clays, depends upon external applied loads. So the option which holds good out of these four question is more in well compacted clays. It is obvious because when you compact the soil, then because when we compact the soil, then what happens is the liquid, the moisture content or the air voids, whatever are present in between the soil particles, gets expelled out, and hence helps to combine the soil particles which has been dispersed away. They get closer and they form a dense, or we can say the compacted clays can be formed. So as a result of which the cohesion is also increased. Okay, so sixth question is the quantity of seepage of water through soils is proportional to coefficient of permeability, total head loss through the soil, neither A nor B. So for this we'll be knowing from this one. Okay, so we have the relation that coefficient, let's suppose coefficient of what is here, quantity of seepage, let us suppose that is q, that is q. Okay, q equals, we have the relation k h ks times nf by nd. Okay, nd. So here k is the coefficient of permeability, h is the total quantity head loss, and nf is the number of flows, and then nd is the number of nf by nd, number of flows and number of uh, drops. Yes. So from this relation, it is pretty much clear that the quantity of seepage of water through the soil is proportional to what? K and IH, coefficient of permeability and the total head loss. Also, as well with the NF, number of flows. So the option will be here the both A and B. Okay, so option will be A and B. Okay, so moving to the next question. When drainage is permitted under initially applied normal stress only though, and full primarily consolidation is allowed it to take place, the test is known as which one? Quick test, drain test, consolidated undrained test, none of this. So quick test. Quick test is basically a test where the soil is permeability of water through soil is allowed. So this means what? It is also known as the consolidated undrained test. Okay. The minimum water content at which the soil retains its liquid state and also possesses a small shearing strength against flowing is known as. What is it saying? The minimum water content at which the soil retains its liquid state, okay, and possesses a small shearing strength against flowing is known as liquid limit. Okay, liquid state, then obviously liquid limit. Okay, the next question is the maximum value of effective stress in the past divided by the present value is defined as over consolidation ratio. Yeah, it is good. So in the other way, how we can memorize this? So for this, there is a I have some the thumb rule, kind of thumb technique or the rule. Let's suppose over consolidation ratio. Let's suppose I have a friend. In the past, he used to be the humble one, but now he has gets over. He reacts overly in every circumstances. So means what? We're comparing with the past and the present value. So if in the case of effective stress, if we're comparing the past stress in the past, effective stress in the past with the present value of the effective stress, then it is called as over consolidation ratio. Okay, so the OCR or the over consolidation ratio when over consolidated clay is more than one, more less than one, none of this. Okay, so for this we have three things. Okay, so if the value of OCR over consolidation ratio is in case of what over consolidated clay, OCR value becomes more than one. For normally consolidated clay, it is equal to one, and if it is under consolidated clay, then consolidation ratio OCR becomes less than 1. So which one will be the correct option? Over consolidation means more than 1. Okay, so here a flow line makes angle theta 1 and theta 2 with the normal to the interface of the soils having permeabilities K1 K2 before and after deflection. Okay, according to the law of deflection of the flow lines at the interface of the dissimilar soils, which one will be the correct option? So for this, option C is the correct one. Okay, so here we have the 10th number question, that is under reamed piles are generally driven piles, board piles, precast piles, all of the above. So first we have to know what under reamed piles are. So in case of under reamed piles, what happens is at the bottom level of that there is a bulb like structure. Sorry. So we can use our common sense here. So if that has a bulb at the bottom, then let's suppose we are hammering over that, then what will happen? Obviously the structure will collapse, or some distortion will take place. There is more chance, there is more probability that in the bulb which is being attached at the bottom level of the under rimmed piles, that gets damaged due to hammering, because we are forcing it to go inside of the soil, right? So it is pretty much unpractical, I would say. So if we just dug up the hole and we just put the same under rimmed pile into it, and we just and then backfilling is done, then it will be the safe procedure of doing so, and getting the required amount of strength whatever we are expecting from that under rimmed pile particularly. So what will be the option one? Option driven pile, board pile, precast pile. So precast means which are being previously made, which are already made in the labs. So this is not happens. So driven piles, not we are not driving, we are just board pile. Board pile means we are digging up the hole and we are just putting the pile into it and then backfilling. So the right option will be board piles. So in the 11 number question, pick up the clay group, clay soil group which does not swell when wet from the falling. Kaolinite group, iolite group, vermiculite, montmorillonite. Okay, so the option will be the iolite group. So we have the different groups of soils that are given here: the kaolinite, iolite, vermiculite, montmorillonite. So if we remember about something about the black cotton soil, then obviously one is familiar with this particular group of soil, that is montmorillonite group. It the amount of this particular group exceeds in the black cotton soil. So because of this, what happens is uh, any type of structure, construction of any type of structure in black cotton soil is prohibited. So because it swells excessive and shrinks very much more. So both the procedures, that is drying and the shrinkage or the swelling, both these two things happens so rapidly. So we generally don't recommend constructing anything in the montmorillonite group. So kaolinite group is that which swells a little bit. It swells, but it very similar value. If we talk about vermiculite group, then more than kaolinite group. But if we talk about iolite group, then it generally doesn't show any swelling property when in presence of moisture. So the answer will be the iolite group. Okay. So in 12 number question, here is given a compacted soil sample using 10% moisture content has a weight of 200 grams and mass unit weight of 2.0 gram per centimeter cube if the specific gravity of soil particles and water are 2.7 and 1, the degree of saturation of the soil is. So it is basically what it is asking us is that it is asking us about it is asking us about the degree of saturation. So we have some formulas, right? We have some formulas. that is gamma d, dry density equals gamma bulk or simply gamma upon 1 plus w. The first formula is that. So from here we can easily find out the dry density of the soil, because we have the soil moisture content, right? Gamma d equals gamma bulk. Gamma bulk means what? Total weight. So this one is unit weight of soil, 2.0, 2 upon 1 plus 10%. So from this we can easily calculate. From this we can easily calculate the, let's do some the numerical. Let's okay. So a compacted soil, so 1 upon 1, no 1, 2, 2 upon 1 plus 10 upon 100. So the value is coming out to be 1.81. 1.81. From this we just calculated gamma d. It is asking us about degree of saturation, that is SR. So we have a relation Sehwag, that is SE equals WG. So gamma d equals, so we'll be going to using the formula of soil particles, that is, so we do have the another formula, that is gamma d equals G gamma W upon 1 plus E. So from here we have to calculate E, right? Because in the formula we have to require just E equals WG, because we are provided with the G W, so the missing portion is the E only. So for this we have to use the formula, this one, G gamma W means 1 upon gamma D minus 1. So now the value of E is coming out to be 0.485. So the moisture content is G S E equals WG. G means 2.7 upon E. So the value is coming out to be 55.67 percentage. So the option B will be the right answer, right? Okay, so option B will be the right one. So here a partially saturated sample of soil has a unit weight. It has given us unit weight, specific gravity, moisture content, degree of saturation. So we just have to apply the formula SE equals WG. Sehwag, one of the cricketer. It is pretty much easier to memorize the formula in these ways. So SE equals WG. W we are provided with, G we are provided with this one, SE. So we are not provided with the E. So what it has given us, that partially saturated means it is not dry soil. It is not dry unit weight. It is partially saturated means bulk. So the same one, gamma D equals gamma means W gamma of soil, that is 2 upon 1 plus water content means how much given, 20%. Okay, the value is coming out to be 1.67. Value is coming out to be 1.67. Again we have to calculate E. So for this, gamma D equals G gamma W upon 1 plus E. So G gamma W 2.6, G gamma W 1 upon gamma D minus 1. So this is coming out to be 0.56. 0.56 WG. G is 2.6 here, 20 upon 100 into E, that is 0.92, or we can say the 92 percentage. Okay, so the value is coming out to be the 92, so the option C will be the right one. So according to Coulomb's wedge theory, the active earth pressure slides the wedge. So in case of active earth pressure, what happens is the wedge slides outward and the downward. Okay, so the option A will be the right one. Stokes' law states that the velocity at which a grain settles out of suspension, the other factors remaining constant, is dependent upon size of grain, weight of grain, size of grain. So from the equation of Stokes' law or the velocity, we can easily know on which factors does it depends upon. So the answer E will be right, the right one. So okay, so in each video lectures we're going to be dealing with 15 to 20 questions. So it will be helpful for both the parties, you and me as well. So hope you guys will like it and to support. So we'll be meeting in the another video with the same topic under different questions. Okay, so take care.